All right. Hi, everybody. We are going to attempt to take a look at light bulbs, which we're going to approximate ohms, that they're ohmic. All right, good enough. And I've got two different types of light bulbs. So the light bulbs, by the way, this is just a holder, and they're just these little tiny flashlight bulbs. All right. You see at the end of it has a little metal tip and the black stuff around it. So that's the metal tip is one terminal, and then the screw-in part on the other side is the other piece of metal for the other terminal. And when you screw this thing in here on the holder, when I screw it in there, this top part of the holder touches the screwy part, and the little bottom part touches the bottom metal plate. And the bottom metal plate's connected to this side, which I can clip onto, and the top screwy part connected to this is connected to that one. So this is how I can connect a wire to the bulb, and this just holds it, and then this connects to the two different terminals of the bulb. So we're going to use two different types of bulbs. What I call, I'll hold these up front. See the little squat one right here? I call that the round bulb, just because. And this one's longer, so I call it the long bulb. All right, so when you are collecting your data, just identify those as the round bulb. I use an R for the resistance with subscript R for round, and R for resistance, subscript L for long. So I've already got a couple of things set up. First thing we need to do is figure out the resistance of the round bulb and the long bulb. Okay, so I already have my circuit all set up here. Here's my current probe. I've got on a different computer over here, a classroom computer, I've got Logger Pro with the readouts so I can get the resistance. I'm just going to use a 1.5 volt setting. So you hopefully can see, let there be light. I can't because there's something in the way here. You can't see it, but I can. There we go. Turn that off. Turn that on. Beautiful. So the current going through the round bulb, you want to write this down. I'm not going to write it down. You write it down. The current going through the round bulb is 0.224 amps. 0.224 amps. And the voltage is, let me see here. I'm going to put, negative over here and positive right there. And the voltage is 1.406. 1.406. Okay? I want to show you something. This is an AP question. If I put the current probe on the other side and measure the current, there was a question on the AP exam, does current get used up in a light bulb? No. All right, I shouldn't have said that first. The current doesn't get used up in a light bulb. The energy, which is measured by the voltmeter, gets used up. The current passes through. The charges don't get used up. The charges pass through the, let me see, I'm going to go from here to here. The charges just pass through the light bulb, go through the circuit, go through the battery, go through the light bulb, go through the wires, go back to the battery, go through the light bulb. The current doesn't get used up. Charges are real things. They just keep going around and around and around. And I can prove that. So what I've just done is moved the ammeter to the other side. So now I've directly connected the light bulb to the positive side. Now I'm going out of the light bulb to the ammeter and then back in here. And now that I've done that, I look at my current, and it is 0.22-ish, all right? So that's more or less the same value. I want to go back to my original setup because that's what I have drawn on the other one. That's an important point. Current does not get used up in a circuit. Current can slow down in a circuit, all right? When you add more resistance to a circuit, then there's there's going to be less current. But overall, what am I doing? Coming out of that, going into here, and then I am going from here to here. Alrighty, let there be light. All right, about 0.22. So I'm back to the original. So the current, and that's going to be a really important point here, is that current. If you think of charges like driving on the freeway and there's just a bunch of traffic, there's no off ramps here, all right? And the current in this is constant, 0.22 amps. Here, 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 here. It's 0.22 amps, all right? We're going to see that it's constant here too because there's no off ramps off of the freeway, all right? So whatever the current is right here, it's going to be the current here, it's going to be the current here, it's going to be the current there, it's going to be the current there, it's going to be the current there, it's going to be the current here. Over here, there is an off-ramp. The charge is going to either go through that bulb or through that bulb, all right? So the current will split. It's all together here. It comes here, and some of the charges go one way, and that's what current's measurement of charge flow. Some of it will go that way, and then it comes back together again, and it goes back here. The current on this side will be the same as the current right here, all right? And then it splits, comes back together, okay? So that's what we're trying to look at. So here we've got the measurements for the round bulb. Let's do this for the long bulb. I want you to calculate the resistance of each, the long bulb and the round bulb and the long bulb, all right? You typically would be doing this yourself. There's a lot of value in putting this stuff together. So if we do get back before the end of the school year, I might have you do this, time permitting. So here's the long bulb. And the voltage, I haven't to connect the voltmeter here. So let me see. Here's the negative, there's the positive. The voltage is 1.495. And the current's 0.055. So the voltage was 1.495 and the current was 0.055. So from that, calculate the resistance in each. Okay? Now I want to go here, and I'm going to use the round bulbs for these. And sadly, I need to go get another wire. Don't go anywhere. I'll be right back. I'm still here, just looking for wires. Yikes. Whoa, 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 whoa. Okay, here I come. So I going from the ammeter, I've gone into one bulb. I'm going to go out of that bulb. And these are two identical, well, more or less identical round bulbs. So I'm going to come out of this first round bulb and go into another round bulb. And then come out of this and go into, where's the other end of this? Go into this other end right here to complete the circuit. But before I do that, you saw how bright the individual bulb was? So if I just, that's the individual bulb. By the way, notice something? This is actually something I wanted to talk about. Where is something to erase this? Oh, right here. And where's my whiteboard marker? God knows. Oh, right here. If I did this, I bet you missed being here. I bet you missed those bells. This is what I have. This is what I have right now because this one is still connected, but it's not connected on the other side. There's nothing attached to that. It's just connected right here. Notice that this bulb is lit. This is very AP-ish. So this bulb is lit, and there, so because this is at a higher potential, then this is at a lower potential. So let's just say this is, I'm just going to make up a number for a second. Let's say that this is at about, about 1.5 volts. This is at roughly 0 volts right here on either side. So there's a 1.5 volt difference. Well, this is at 0. That's at 0. So it means this is at 0. So that's at 0 and that's at 0. They're at the exact same 0 potential. So there's no potential difference. And so that bulb's not going to light up. If I were to do, if I were to do the same thing with the first bulb. So the first bulb is kind of just left in la-la land. So what I've just done now is I have the first bulb, the wire goes straight to the second bulb, and the first bulb is out here. So this is the second bulb right here that's lit. This is the first bulb. So if this is at 1.5 volts, this is at 1.5 volts, which means that's at 1.5 volts, which means that's at 1.5 volts, which means this right here is at 1.5 volts. The whole first bulb is at 1.5 volts. But it's at 1.5 volts on both sides. If you think about this like air going through tubes, and you turn on the pump, and like these are propellers, all right? Well, this propeller might turn for an instant, but it's going to run into a dead end. And the whole thing's at a certain pressure, air pressure. And so it's just going to push in, and then there's no air that's going to flow through there because it's all at the same pressure. And so nothing's going to happen. Again, it might happen the very first instant you turn it on, but it's going to stop real quick. The thing's at the same potential, this whole side of the battery, all the way here, 1.5 volts, 1.5 volts, 1.5 volts, 1.5 volts, 1.5 volts, 1.5 volts, 1.5 volts. It's all at the same potential. You only get current flowing when there's a potential difference, and there's no difference over here. There is a difference here because that's connected to the 0 volt side of the battery. So this goes from 1.5 volts down to 0. And so that's why that bulb lights up. That's a really important idea. Ooh, I'm going to connect these together, and then I'm going to shut this off and pick it up and just, it'll shut it off now and connect them, and we'll pick this up in just a moment because I'm running out of time. I have a 15-minute limit on YouTube, so here we go. We'll do part B in a moment.